All right, section 10.3, I've got it split into two parts. The first part was just introduction to polar coordinates. In this part, we're going to start looking at calculus with polar coordinates. So first up, let's look at how to find the slope. So if you're given a function, r is some function of theta, what you do is you treat theta as a parameter, and then you use these two little equations here to rewrite x as a function of theta and y as a function of theta. Now, where did these two equations come from? Well, those come from essentially the same place as the unit circle. If you've got a point over here, this point is x, y, then this distance here, of course, is x, and this is y. And we're going to call the distance out to it r, and this angle right here is theta. And so if you do sine of theta, that's going to be y over r. Or you could multiply both sides by r and get y equals r sine theta. And the same thing happens for cosine. Cosine theta is x over r. Multiply both sides by r, you get that. So once you've got that, you can find dx d theta and dy d theta. Put them together, and you get dy over dx. So let's look at an example. Find the equation of the line that's tangent to r equals 1 plus cosine theta at theta equals pi over 2. Okay, so first up, this is going to get a little bit messy, but first up we have to use this to come up with our x and our y. So x is going to be 1 plus cosine theta times cosine theta, and y is going to be 1 plus cosine theta times sine theta. All right, so now multiply that out. Let's see, we get cosine theta plus cosine theta squared. Let's see, this gives us sine theta plus cosine theta sine theta. All right, now we've got to take the derivatives of these guys. So dx d theta, derivative of cosine is negative sine. Derivative of this, got to use the chain rule. So you get 2 times cosine theta times derivative of the inside function. Derivative of cosine is negative sine. I am going to take the negative and just go ahead and put it out front. And over here, dy d theta, derivative of sine is cosine. First times derivative of the second, derivative of sine is cosine, plus the second. So that's sine theta times derivative of cosine. Derivative of cosine is negative sine. So we get all that. So now you might say, okay, let's go ahead and write it out then. Dy over dx is going to be all this stuff over all this stuff. And that's correct. But to cut down on the amount of copying we do, let's go ahead and plug in the pi over 2. And after we do that, we'll assemble this together. So plug in pi over 2. When I do that over here, let's see, sine of pi over 2 is 1. Cosine of pi over 2 is 0. So I get negative 1 here. And when I do the same thing over here, plug in pi over 2, cosine of pi over 2 is 0. Cosine of pi over 2 is still 0. And sine of pi over 2 is 1. So I get negative 1. So this is fortunate because it's easy. Dy d theta, or I'm sorry, dy dx is dy d theta over dx d theta. Now in this case, both of these are the same thing, but in general, be careful when you do this, because you do all this work up here. Make sure you put the right one on top and the right one on bottom. So in this case, dy d theta was -1 and dx d theta was -1. So we get a slope of 1. All right, now we've got to figure out what the x and y coordinates are. At theta equals pi over 2, the x coordinate, I'm going to go back in and I'm going to plug in to here and then into here. So the x coordinate is going to be cosine pi over 2 plus cosine pi over 2 squared. What is cosine of pi over 2 though is 0. And the y coordinate is going to be sine pi over 2 plus cosine pi over 2 sine pi over 2. So sine of pi over 2 is 1 and cosine is 0. So we're looking at the point 0, 1 and the slope. What is the slope? The slope was 1. So y minus 1 is equal to 1 times x minus 0. So you get y equals x plus 1. All right, let's graph this and see how it looks. Now, if I turn Desmos on, I've already got the picture, the graph drawn. If I graph y equals x plus 1, well, first of all, what's the point we're looking at? We're looking at the point where theta is pi over 2. That's going to be, straight up the y-axis. So we're looking at this point right here. And I guess we did just figure out what the point was. It was 0, 1. So we're trying to find the tangent line that goes through that point. And the tangent line we came up with was y equals x plus 1. And sure enough, that's the right one.